Good morning, GLA middle schoolers. Today's date is Tuesday, May 19th of 2020. It is way past my bedtime because I've been up all darn day preparing this lesson for you guys, and I'm super excited to actually kick it off. It is something that you've been asking for all year long, that some of you guys told me that we needed to have this in science class all the way back in August, and we are finally doing it. Ladies and gentlemen, we're making elephant toothpaste today. Woo! Alright, experiment 3, let's get cracking. The first thing that I got to do is shout out some students who've been sending me pictures and videos of them trying out the experiments that we've been doing so far. We got a whole bunch more people that we added to the list. For example, we got Michelle right here, who was making oobleck today. We got a bunch of people who attempted our invisible ink experiment from yesterday, and what I've learned is that the grape juice method didn't work so good for some people. The heat method seemed to work pretty well for everybody. But that's what science is all about. It's about trying stuff and learning it and improving it and trying again. So I had Anaya at home trying, or I think this one was actually from Cadence, trying the grape juice method for the invisible ink. I had JL doing all three methods for the invisible ink. I had Anaya as well giving it a shot. I had Charles doing the invisible ink. And I had Cameron as well making invisible ink and writing secret messages at home. Props to all of you guys for all of your hard work. And that is 4 more people who have now done experiments at home. That brings our total list up to 11. And if you watched yesterday's video, you know I did promise if we make it to 15 students who do at-home science experiments and send me pictures and videos, then this guy right here is getting a much-needed haircut. We're at 11 right now. Let's see if we make it. Alright, a reminder, in case you still want to do the experiments, get the materials that you need. Here are the materials that we're looking at. We've already done this one. We did oobleck. We've already knocked out this one. That was on invisible ink. Today is elephant toothpaste. And then tomorrow, I won't reveal just quite yet, but it's going to be a grand old time. And just to kind of situate you in where we're at right now, we had experiment 1. We had experiment 2. Today is Tuesday, May 19th. We're doing experiment 3. Tomorrow we'll have number 4. And then we have a unit test on Thursday. We're using these experiments to help us review. So don't just do the experiment and say, darn, that's cool, I have no idea what's going on. The point of these experiments is to understand what's going on and to review for our test coming up on Thursday. Speaking of tests and people doing some excellent work in their online classes, I got to give some more shout-outs for responses to yesterday's classwork question video about what's one situation in which you might need to use invisible ink to write someone a secret message. I got this answer from Charles. He said, I would use the invisible ink to write a secret message to my sister about what we're going to do for our dad on Father's Day so he won't know. Wow, what a good son. I'm jealous. We had this one from Kiara, which I really enjoyed. She said, you might need to use invisible ink when you're talking to someone about money. Lots of money, and you don't want no one to know. That's a great application. That could very much be true. People get all mixed up over money. We had Vickiana, who said, if there was a case that a robber broke into your house, and you need to write someone a secret message that only that person can understand, that would be an excellent use of it. We had Kai, who said, if I'm ever on a show, like Total Drama, I might need to tell who to vote off who. I've never seen this show, Total Drama, but it sounds like it's similar to a show called Survivor that we watched back when I was growing up. Where, yeah, it's like a game show, and you need to exchange secret messages to vote people off the island. And, oh my goodness, Lanaya. Lanaya really said this to me. She said, in class, so a teacher won't catch you when you're passing notes. Well, hey, here's the deal. If you ever use invisible ink to pass notes in class, and the teacher catches you, you did not learn how to do that from Mr. Manta, okay? If you say my name, that means we can't do more fun experiments going forward. Alright, moving on from there, I also want to add a clarification, because yesterday for classwork question number 1, we had this question, and I noticed a lot of people making the same mistake, and I want to clear that up right now. The question was this: is dissolving baking soda in water a physical change or chemical change, and how do you know? Now, a heck of a lot of people said that this was a chemical change, and they thought that it was because you couldn't undo it, okay? Many people said this would be a chemical change because it can't be undone. And ladies and gentlemen, don't feel bad if you said it, because a lot of people did, but that is wrong. That's just not true. Let me explain. Anytime we make a solution, and we're trying to figure out if it's a physical change or a chemical change, solutions actually can be undone. Solutions can be separated back out again, generally by boiling them. So if I, for example, mix baking soda into water, then if you boil off the water and turn the water into a gas, you will be left with whatever your solute is, something like salt or baking soda. So dissolving a solute into a solvent, making a solution, is always going to be a physical change. It will never be a chemical change. Remember this for the test, ladies and gents, because it will definitely show up. Making a solution is always a physical change. Write this down in your notebooks now. Making a solution is always a physical change. Some other examples of things that are always physical changes are these things. Anytime something melts, when something freezes, when something boils, or when you, like we're saying, dissolve something, those are all physical changes. They can be undone, just a change in the state of matter, from solid to liquid to dissolve to whatever. Alright, moving on from there, we're finally getting to today's do now. Oh my goodness. Oh gosh, I didn't even write the header right up on here. Alright, it should say Unit 6, Experiment 3, Elephant Toothpaste. Number your notebooks numbers 1 through 10. Go ahead and answer these first 5 do now questions now. Alright, I'm assuming that you paused the video and you did that. So I'm going to go ahead and show our next questions, number 6 through 10. Pause the video again and answer these 5 questions now. Alright, now I'm assuming that you answered all 10. Let's see some answers. Number 1. When we made invisible ink yesterday, baking soda was the solute in our solution. Number 2, water was the solvent in our solution. You always mix the solvent into the salt. Oh my goodness. You always mix the solute into the solvent. Number 3, is dissolving baking soda in water a physical change or chemical change? That will be a physical change. That's what we just explained. Number 4, a lot of baking soda can dissolve in a little bit of water because it's highly soluble. That's that word we learned. Number 5, if you add too much baking soda, the solution will become saturated. That means it can't absorb any more solute. For 6 through 10, let's go. Number 6, which kind of change can be undone? A physical change or a chemical change? That will be a physical change that we can undo. Number 7, in which kind of change is a new substance created? A physical change or a chemical change? Well, that one is a chemical change. Number 8, which kind of change has 6 signs you can observe to see if it happened? A physical change or a chemical change? This one is also a chemical change. We have those 6 signs like creating a smell, creating heat, changes in properties like color, something fizzing, can't be undone, all those 6 signs. Number 9, in a chemical reaction, the stuff you start out with is called the reactants. And number 10, in a chemical reaction, the stuff you end up with is called the products. Those will be relevant today because you can bet we are having a chemical reaction go on. Alright, now introduce today's experiment. Dun, 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 dun. I already told you at the top, but I want to make it exciting. Folks, we're making elephant toothpaste. Woohoo! Man, now some parents who are watching this video are probably getting real nervous. They're saying these videos look crazy. I don't know if I can handle doing this at home. Well, don't worry, and students, don't get too excited right now because we're doing the safe to try at home version of elephant toothpaste, which is going to be much more low-key than these videos. If you like seeing it, then you can go on the million elephant toothpaste videos on YouTube, of course. But we're not going to do anything so crazy as this because we don't have the materials on hand and we probably don't have the right kind of space and the ways that we can do it safely like these folks are doing. So, in order to, we have to get ready for big brain time here today. Because in order to do, the point of doing elephant toothpaste is not just to see how cool it is and to see how funny it looks. It's to actually understand what's going on inside of those bottles. I could not justify my job as a science teacher if you guys ended class thinking that the point of elephant toothpaste was just to make this thing explode and look funny. The point is to understand why, when you mix these two liquids, this crazy reaction happens and you get this really cool looking stuff called elephant toothpaste. And understanding why is pretty difficult, even for us, having gone through all these chemistry lessons. So, I'm going to ask you guys to get ready for big brain time, because we're going to learn a whole bunch of bonus material today at a high school level. That's why I've included this picture from 21 Jump Street and this picture of this guy thinking real hard. Because we have to explain some pretty advanced stuff to understand why elephant toothpaste does what it does. So get ready for this. If it's not making sense, don't stress out too much. There's only one important part of this today that's going to end up on the test. Alright. When we introduce these experiments, today is experiment 3. I listed you guys all the things you might need to make this experiment happen. And, well, today's experiment 3. And the key ingredient for today's experiment is this stuff called hydrogen peroxide. Maybe some of you have heard it before. I hadn't heard of it until like a couple years ago when I was, getting ready to become a science teacher. They never did this experiment when I was in 5th grade. So, I want to first explain a bit about this hydrogen peroxide stuff because our entire experiment hinges on this. Hydrogen peroxide is a common and fairly safe household chemical. A lot of people probably already had this at home, and if not, you can go out to any grocery store, Walgreens, and buy it there. It's often found with other medical supplies like band-aids and rubbing alcohol. Here's a bottle of hydrogen peroxide. Many people use it as a cleaner or for treating wounds or for styling hair. So it's a common chemical used around the house. It's useful in a lot of different ways. Another cool thing about hydrogen peroxide is that it's actually a solution. The bottle of hydrogen peroxide that you buy in a store, which looks like this, that bottle you buy in the store isn't pure 100% hydrogen peroxide. That would be like way too strong of a chemical to just sell to normal people. Instead, it's just a little bit of hydrogen peroxide mixed into other liquids, like water and some other stuff mostly. So anytime that you buy a bottle of hydrogen peroxide, like this one that we have in the picture, it will say somewhere on the bottle what percent of hydrogen peroxide it is. So this one is actually only 3% hydrogen peroxide, and then what, 97% other stuff. Most of the time when you buy hydrogen peroxide, it's either 3% or 6%. Maybe some of you guys at home have like 12% hydrogen peroxide. Basically, the higher the percentage is, the more extreme today's experiment is going to be. I'm using just 3%, but if you have 6%, or if you're able to find 12% hydrogen peroxide at a beauty shop or something like that, then that will make the experiment even more exciting. But hydrogen peroxide is already a solution. Now, to get really advanced here, we have to look at the molecules. A hydrogen peroxide molecule, and we learned what molecules are, is pretty similar to a water molecule. So here's the deal. I'd actually like you to look at the pictures first, right? So here's a water molecule, and we saw this picture earlier in this lesson. And then the water molecule has one oxygen atom, and it's attached to two hydrogen atoms, right? So they call it H2O, right? That's a water molecule. Down here we have a hydrogen peroxide molecule, which is very similar. The difference here is that we have two oxygen atoms as well as two hydrogen atoms, right? So the only difference is that there's a second oxygen atom. Up here you only have one, down here you have two, right? And then you always have two hydrogens. So that's the difference. Water has two hydrogen atoms and one oxygen, whereas hydrogen peroxide has two hydrogens and two oxygens as well. There we go. Now, that's important because it starts to explain why elephant toothpaste happens, why you can make elephant toothpaste out of hydrogen peroxide. Hydrogen peroxide decomposes over time. What this means is that if you just leave it alone long enough, its molecules break apart little by little. It takes a really long time for it to happen, days, weeks, months, even years. But what's going on is that these molecules down here of hydrogen peroxide break apart into molecules of water and then oxygen. So you can't have hydrogen peroxide forever. It's always kind of breaking down into water and oxygen. This happens just naturally. You don't have to add anything to it to make this happen. It's always happening slowly in the background all the time. So if you have a bunch of hydrogen peroxide over here and you wait a month and then you take a look at your bottle again, there's going to be less in it because it's constantly decomposing. The molecules are breaking down all the time. This is an example of a chemical change, right? So we remember when we talk about our chemical changes, we always have our reactants, then we go through a chemical reaction and we end up with our products. Well, what's going on here with the decomposition of hydrogen peroxide is that we have our reactants. We have these tiny little particles, these molecules of hydrogen peroxide that look like this. And over time, very slowly, just naturally, they're going through a chemical reaction. And that chemical reaction is creating the products. Over here on the product side, we have water molecules, H2O, as well as oxygen molecules, which are just two oxygen atoms bonded together. Yes, this is getting very advanced. Hang with me. This is a reaction that happens very slowly, where we have one reactant and two different products, and it just happens on its own over time, which is different in some ways, but similar in some ways to the other chemical reactions that we've talked about in class. Now, since this happens so slowly, it's not very exciting. It's kind of just a pain in the butt because it means your hydrogen peroxide is slowly decaying all the time. So you, like me, might be asking, how can we make it go faster? Like this little kid, I want to go fast, right? So here's the thought. In order to make this whole process here just happen a lot faster, we can add something called a catalyst. This is the new word for today that, yes, you are now responsible for knowing. It's called a catalyst. C-A-T-A-L-Y-S-T. And here's what it is. A catalyst is something that makes a chemical reaction go faster. Write it down in your notebooks. I put a picture of Sonic the Hedgehog here because, as many of you know, Sonic likes to go fast. And a catalyst makes something else, a chemical reaction, always go faster. It never they're never essential. They never start the chemical reaction and actually take part in it. They just make it go a heck of a lot faster. So, for example, if I had some hydrogen peroxide with no catalyst, it might take days or weeks or even months to have it decompose from this amount down to this amount. Not very exciting, a very slow chemical reaction. But if I add a catalyst, a really powerful catalyst, all of a sudden that happens not over months, but in just seconds, as this hydrogen peroxide decomposes, what we would say, catastrophically, super, super fast, right? So here we're adding a powerful catalyst and just making this thing happen a million times faster, right? Okay, that's a lot of background knowledge. You're probably saying at this point, gosh, can we just do the experiment already? Well, now that we know what's going on in our experiment, yes. All right, I'll pull up the video. Give me just a second, and thank you for being patient. Alright, now that we've got all that background knowledge taken care of, we are ready to make some elephant toothpaste. Experiment number 3 is go. Now, of all of our experiments, this one so far is one that's probably the most complicated, but it's still not so involved that it's too difficult for you guys to do at home. I do have a lot of materials right here, but it actually looks like more than it really needs to be for you guys to do this at home, because I'm going to be doing 2 different versions of this experiment. So it's really not that much if you're just doing the main normal version of elephant toothpaste. Let me explain everything that I got going on here. First of all, I got a nice tray. You need some kind of tray or bin that you're going to do the experiment in, because this one's going to be a little bit messy, and I'm also going to take it outside so that when I actually make my elephant toothpaste, as it foams up, I don't create a mess inside the house. I'm going to be doing 2 versions, like I said. For the first version, it's just going to be the most simple, basic chemical reaction version of the elephant toothpaste experiment. And for that, all you need is an empty bottle of some kind. It can be glass, plastic, whatever. You're going to need some warm water and yeast. And what you're going to do is mix, like, I don't know, a few tablespoons of water maybe, and a tablespoon of yeast to create what is going to end up being a yeast solution, like this one. So all I did here was I took a tablespoon of yeast and I just stirred it into some warm water. I did this ahead of time because it takes a little bit and I didn't want to make the video super slow. And lastly, you need your actual hydrogen peroxide. The basic version of the experiment is just combining hydrogen peroxide and a yeast solution in an empty bottle. Now, this version of peroxide that I have, like we said, there's different strengths of hydrogen peroxide, and this peroxide itself is a solution. This is actually 3% hydrogen peroxide, because that's all that I could find at Walgreens, which means that 3% of the liquid in here is hydrogen peroxide, and the other, 97% of it is water. The stronger peroxide you use, the more exciting your explosion is going to be, but this is going to be the kind of the low-key, safe-for-home version of it. If you have 6% peroxide around, use that. If for some reason you folks have 12% or higher percent, then definitely have parent supervision, but you can try that as well. And that's going to be the basic version of our experiment, right? So I'm going to put that off to the side. Now, for the proper elephant toothpaste version of our experiment, some things are going to be the same. We're going to have another empty water bottle. We're going to have another yeast solution that I made of warm water and yeast. And we're going, of course, going to add in a couple cups of hydrogen peroxide. But in order to make the reaction be not just a chemical reaction that releases a gas into the air, but actually makes this thing that looks like toothpaste that we call elephant toothpaste, we're also going to be adding some dish soap and a little bit of food coloring. Whatever color you like. I have blue, because when I see toothpaste, it's usually blue. But you can have red, green, yellow, whatever it is that you would like to be. Alright. I also want to add, and these are tips, these aren't required, but they're highly recommended. This hydrogen peroxide stuff can be a little bit, tricky to work with, because if you leave it on your skin for a long time, or if you get it on your hands and you touch your eyes, it can bother your eyes a little bit. So I am using the safest version here, but even to be extra safe, I'm also going to go ahead and put on my safety goggles and a couple rubber gloves that I had hanging around. And then I'm going to gather up all the materials here and take them outside so that we can actually have a nice clean workspace. I'll see you guys outside. Alright, now like I said, we're going to start with the most basic version of our experiment, which is just going to be combining hydrogen peroxide and a yeast solution, which is our catalyst, in a water bottle to see it react and fizz up and create a gas. So let's get what we need there. I'm going to move you out of the way, and you, and one of you, and one of you. Don't need food coloring. Alrighty. Now, to start off, the base of our reaction is going to be the hydrogen peroxide itself inside the water bottle. For this one, I'm using 1/2 of a cup and maybe a 1/4 cup or so, more than that, so maybe 1/3 of a cup of yeast solution. Now, like we said, hydrogen peroxide naturally reacts with oxygen in the air and decomposes, or it doesn't even react, it just decomposes. If you leave hydrogen peroxide alone for enough time, it will decompose into oxygen and water. Adding the yeast catalyst to it is going to make that reaction happen even faster. So, if I take my hydrogen peroxide, where I've got right there, and if I take my yeast and I add one into the other, we can right away see some of the signs of a chemical reaction. It's starting to fizz up a little bit. That actually is fizzing up a lot more than I expected it to. But it's not making quite what we would say is proper elephant toothpaste, if you've seen it before. I'm going to take it carefully and give you guys a closer look at what we have going on here. And all that's really happening from a chemistry perspective is that all that hydrogen peroxide that was in our solution is breaking down and creating oxygen gas and water. And all that oxygen gas is trying to expand and take up more space, and so it's filling up and foaming outside of the water bottle. If I think about there are the 6 different signs of a chemical change happening, I can see at least 2 of them happening right here. First of all, we see something that is clearly fizzing up and creating a gas. That's often a sign of a chemical reaction. And second of all, you guys can't see this one, but when I touch the bottle itself, it feels pretty warm, a lot warmer than anything that I put into it. This reaction is exothermic. That's a fancy way of saying it creates heat when you combine these different things. So with those 2 signs, I know for sure that there's a chemical change going on here. So that was pretty exciting, right? We took our hydrogen peroxide, catalyzed it so that it broke down and created this foaming gas. That's not proper elephant toothpaste. In order to make real elephant toothpaste, we need a couple other key ingredients. Here's what we're going to add. For round 2, I'm going to have, once again, a plastic water bottle. This time I'm going to start out with more hydrogen peroxide, just because I want to make it more exciting. So I'll do 1 full cup. This is a 1/2 cup measure, so I've got 1/2 cup, and this will now make a full cup. Look at that, we've been practicing fractions. And then once all that oxygen gas is escaping, rather than have it escape, I would rather it catch up into a kind of soapy foam and make what we know to be elephant toothpaste. So I'm also going to add some dish soap. The dish soap is not doing anything special as far as being part of the chemical reaction, but instead it's just making it so that when that chemical reaction that we just saw happens, it gets caught into a foam and turns what we call elephant toothpaste. After adding it in, I'm going to swirl it around just to make sure it gets mixed into the hydrogen peroxide okay, and no reaction is starting just yet. It still is just normal 3% hydrogen peroxide. I'm moving the camera closer so you guys can see this as clearly as possible. You can also see my, oh, Maddie ran away. And the last fun part is to add our food coloring. So I'm going to add a little bit directly into the solution, but I'm also, to make it look like toothpaste, I'm going to drip it along the edges of the cap of the bottle. So I'm going to put, what, 1 right here, and there, and there, and there, which will eventually create our kind of streaky toothpaste effect. Cap that off. And of course, my pre-mixed and ready to go yeast solution. Again, this is just warm water and yeast. It's going to act as a catalyst. It's going to help break down the hydrogen peroxide that's in this bottle. The soap bubble is going to catch it. It's going to create a foam, and that, ladies and gentlemen, is how you make elephant toothpaste. Give it a countdown. Let's have it go in 3, 2, 1. Ta-da! Woo! Look at it. Now I'm going to grab it because I have gloves on, so I know it's not going to mess with my skin too much. I didn't get the toothpaste. Oh, there we go. Now you can kind of see the toothpaste effect going on. And I am telling you guys, this stuff sure is warm. Not dangerously warm, but warm enough that it definitely tells me there's a chemical reaction going on. Man, I am creating quite a mess. Hence being outside and hence having a tray to catch all of this in. Wow, and it does kind of look like toothpaste. Now, I have been told the foam is as safe to play with as just 3% hydrogen peroxide is, which means it can irritate your skin if you're not too careful, and it can be hot if you go too quick, but it is ultimately not going to be super dangerous for you in any way. So I'm going to take a little bit of this foam that I captured, just to show you guys what my elephant toothpaste today really looks like. Alright, that is all that we got for you today. Back to the slides. Alright, and back to the slides we go. I enjoyed doing that a lot today. I had to try like 10 different versions to try to get it even to work that well, and I know even that one wasn't as exciting as what you'll often find on YouTube, so I'll link you guys some YouTube videos to show you how you can make this happen. Now, to recap what we had going on in this experiment, there's 3 different versions of how we can think about this, right? The most plain version is right over here, which is just simply that if you leave hydrogen peroxide sitting around long enough, it naturally decomposes. So that's what it does. The second version is the kind of simple version of the experiment that I showed you, which is that if you add a catalyst like yeast to hydrogen peroxide, you can make it decompose much faster. And in that first version of the experiment, we created just kind of this more plain looking foam that wasn't so exciting, but it's creating all this oxygen gas that's trying to bubble up and out of the solution. And lastly, we have the proper version, which is that if we also add soap and food coloring to this hydrogen peroxide, then we get this thing that looks like toothpaste, and we joke around and we call it elephant toothpaste. And that was the final version of the experiment that I did. Now, if that wasn't exciting enough for you, if you were like, man, really, Mr. Manta, that's all we get to do, then I suggest you hop on over to YouTube, where you can watch some videos of guys who use a heck of a lot more hydrogen peroxide and a much stronger catalyst called potassium iodide that I was not about to use in my videos to create this monstrosity that you're looking at, an elephant toothpaste reaction that's the size of an entire house. It's by this guy named Nick Uhas, I think, on YouTube, and he set the world record for the largest elephant toothpaste experiment ever. That all these YouTubers keep setting the record and breaking it, and setting the record and doing an even bigger one. But I think that's still the biggest one so far, and I'm going to link that as today's cool thing in case you guys want to watch it. Alright, that brings us to today's classwork questions. They're simple. There's only 2 of them. Knock them both out right now. Classwork question number 1 is simply this. Explain in your own words, what's a catalyst? What is it? What does that mean? Classwork question 2, right here, is more of a personal or an application question, which is, would you rather invent a magical device that made things happen faster or slower? You can only pick one. Why would you pick faster? Why would you pick slower? Explain which one you choose, and tell me also, how would you use it? What are some things that you would want to speed up or slow down, kind of like a catalyst? Alright, that brings us to today's, I should mention, like I always do, yes, pause the video and answer in your notebooks or directly into the form these 2 classwork questions now. Alright, moving along. I can't believe I almost forgot that. Folks, it's time for independent practice. There's 10 of them. Number out your notebooks. Numbers 1 through 5 are here. Pause the video and answer these 5 independent practice questions now. Alright, I'm now assuming that you've completed that. Here are numbers 6 through 10. Pause the video again and answer the next 5 independent practice questions now. Alright, assuming that you got all 10. Let's see if you got them right. We'll find out. Here's some answers. Number 1, which kind of change creates a new substance? A physical change or a chemical change? That's going to be a chemical change. Remember it every time. Chemical change, new substance. Chemical change, new substance. Number 2, which kind of change can be undone? A physical change or a chemical change? Physical change, like, melting ice. You can always undo that by refreezing the ice. Number 3, is something gets dissolved one of the 6 signs of a chemical change? No, dissolving things is in fact a physical change. That's not going to be one of our 6 signs. Number 4, is heat is created or absorbed one of the 6 signs of a chemical change? Yes, that is. The creation or absorption of heat, definitely a sign of a chemical change, and I saw that today in the elephant toothpaste experiment. Number 5, are atoms made up of molecules or are molecules made up of atoms? Molecules are made up of atoms, like those pictures that we saw of hydrogen peroxide molecules being made of oxygen and hydrogen atoms. Here's our next 5 answers. Number 6, in a chemical reaction, the stuff you start out with is the reactants. Number 7, in a chemical reaction, the stuff you end up with is the products. Number 8, something you add to a chemical reaction to make it go faster is called a catalyst. Number 9, what do scientists call the different types of atoms that exist? They call them elements. And number 10, how many of them are there that we know of? There are 118 elements, until one day a GLA scholar is going to become a scientist themselves, and they're going to discover number 119. Alright, as always, star those ones you got right, fix the answers you got wrong, and tell me in the classwork form. And folks, that's all for today. I hope you enjoyed the elephant toothpaste lesson. I certainly did. And I will link in today's cool thing the full world record video if you want to watch these guys be super extra and do it in this big, bombastic, crazy looking way. Let's hop out. Ooh, can I play it quick? No, I won't play it quite yet. You have to go watch it yourself. Alright, take care, folks. Talk to you tomorrow.